Well, it's 10:01, so we'll get started. Thank you for joining us today, and welcome to our first of three CNL webinars. We're starting out with the NPD webinar on the development of the safety case. Before I get started, though, I would like to acknowledge the Algonquin Nations, whose traditional and unceded territory most of us are gathered upon today, and certainly where the NPD project is taking place. So I'm Mitch McKay. I'm the manager of stakeholder relations for Canadian Nuclear Laboratories environmental remediation management team. I'm here today joined by several of my colleagues that work on the nuclear power demonstration closure project. And I'll let them introduce themselves in just a moment, but I'll go over some of the notes for the webinar today, some of the logistics. So this is a 1-hour webinar on the topic of the development of the safety case for the NPD closure project. The webinar is available in both French and English. It will be 1 hour long. It includes a 10 to 15 minute question and answer period towards the end. You can access the French and English or toggle between French and English at the bottom of the Zoom platform there. You'll see a little globe icon at the bottom bar to your right. You can select the language you'd like to hear. Just note that there is a slight lag in the translation to French, so please wait for the full translation to come through before you ask your question. I ask that everyone just remain muted, although I think that actually the panelists are the only ones that can come off mute, so I don't think we need to worry about that. There is a QA function at the bottom of the screen as well, and that's where you can type in your questions. So as questions come to you through the presentation, just add them into the question and answer box, and I'll help facilitate the Q&A section and make sure your question gets asked. Please make sure your questions are within the scope of this presentation. If you do have questions that are outside the scope, we're happy to answer them as well, but we'll have to jot them down and get back at a later time. Right now, we'll be focused on the scope of this presentation. So happy to answer other questions, but just note that we'll get back to you at another time with an answer to your question. If you know your question's out of scope and you'd like an answer for it, you can always email us at ermstakeholder@cnl.ca. As well, after the webinar, we will be posting the recorded webinar to our YouTube channel in the next few days, so people can watch it in either language. Okay, with that, I'll hand it over to Graham Porter to introduce himself and the rest of the NPD team.
Mitch. So just let me organize something here. Good morning, everyone. My name is Graham Porter. Today I'll be presenting on the topic of developing a safety case for a radioactive waste disposal facility, specifically in relation to the Canadian Nuclear Laboratories proposed NPD disposal facility. So NPD was the first Canadian power reactor. It operated from 1962 to 1987. It was a relatively small one, 22 megawatts electric. It was a pressurized heavy water reactor. And closure activities were undertaken to reduce the risk, and these included things such as defueling and draining the reactor, transferring the nuclear fuel water to our laboratories. In addition to that, there was also shutdown and removal of systems, structures, and components. We were no longer required to keep the facility in a safe state, and radiological surveys were done to ensure that this was the case. So far, we've had over 30 years of storage with surveillance, and that's all occurred safely. We currently maintain integrity of the facility through a life management program. We do a number of environmental monitoring of releases in the surrounding area. And overall, the facility is essentially kept in a cold and dark condition. Unfortunately, this is leading to a slow degradation of the facility. The facility at the moment is fairly unique. It extends over 88 feet below ground into the bedrock. And CNL's plan is to reuse the existing concrete foundation to create an in-situ disposal facility. The NPD closure project is undergoing an environmental assessment and has submitted an initial draft environmental impact statement. And this was done in 2017. Since that time, CNL has been working to address feedback from Indigenous communities, the public, the CNSC, and other regulatory agencies. CNL is also preparing to submit to the CNSC its revised draft EIS, which will be in December of this year, 2021. This submission will undergo technical review by the CNSC and the Federal Review Team, after which CNL is likely to receive additional information requests to resolve. CNL expects to submit a final EIS for the NPD closure project near the end of 2020-2022. Once the final EIS has been accepted, a two-part hearing will be scheduled. Alongside the EA process that we discussed often during our webinars, CNL has also requested a license amendment from the CNSC for the NPD closure project. And that's what I'm going to talk about today. The current facility is a waste facility, and we usually abbreviate Nuclear Power Demonstration Waste Facility to NPDWF. And when we refer to the disposal facility, we abbreviate the name to NPDDF. So it's a subtle distinction, something to be aware of. Just saves a lot of words when we're talking. The NPD License Conditions Handbook identifies the criteria that will be used by the Canadian Nuclear Safety Commission, or the CNSC, staff to assess the licensee's compliance with the conditions listed in the license. The License Condition Handbook also provides information regarding delegation of authority and applicable version control of documents. In simple terms, the current license requires a facility to be maintained in its present state, so effectively the only activities permitted are storage and surveillance. A license amendment is therefore required to complete decommissioning, construct the NPD disposal facility, and then close it. It is an amendment because all these activities are covered by a decommissioning license. Excuse me. And it is the activities permitted under the license that change together with the associated licensing basis. When the submission is submitted to the CNSC, the Commission, supported by more than 800 scientific, technical, and professional staff, will review the application for a license amendment according to regulatory requirements. They will then make recommendations to the Commission and enforce compliance via the Nuclear Safety and Control Act, its supporting regulations, and any license conditions imposed by the Commission. The Government of Canada has legislation in place that governs nuclear safety and has specific requirements with respect to the nuclear waste disposal, i.e. the Nuclear Safety and Control Act. Beneath this Act are the General Nuclear Safety Case Regulation, Safety and Control Regulations, and the Class 1 Nuclear Facility Regulations. In addition to this, the CNSC also has a number of regulatory documents that are used as a framework for control licensing. Of particular note under the Nuclear Safety and Control Act is Section 26, which relates to the regulations relevant to disposal. Waste disposal is also addressed in the other legislation, such as the General Nuclear Safety Control Regs and the Class 1 Nuclear Facility Regulations. Implementation of the Acts and regulations is performed by the CNSC, and that's governed by a series of regulations, with those specifically applicable to waste disposal falling under the regulation documents 211 series. So why do we need a safety case? A safety case is an integrated collection of arguments and evidence to demonstrate the safety of the facility and the meeting of all applicable regulatory requirements. The safety case normally includes a safety assessment, but could also typically include information such as supporting evidence and reasoning on the robustness and reliability of the safety assessment and the assumptions made inside that. It's also a list of things such as key inputs to the safety case, and those are things like such as safety analysis reports, post-closure safety assessments, waste inventory, etc. The current NPD disposal facility life cycle stage is a submission to the Canadian Nuclear Safety Commission, requesting Commission approval to amend the license to decommission. The safety case for the disposal facility has been submitted to the CNSC as part of the application to create a disposal facility at the Rolphon, Ontario NPD reactor site. safety case will also be updated as required during the life of the facility to reflect the different stages of the facility and to demonstrate how we know more information about as we progress through the project and to improve the information that we have. There are a number of aims of a safety case. And for the NPD one of the major is we have a large number of technical supporting documents. Just an example is we have a post-closure safety assessment, a decommissioning safety assessment, an environmental impact statement, a detailed decommissioning plan, ground wash analysis, and the list goes on and on. So we need to have somewhere to summarize these things. Also, these documents do not cover all the areas required to support the arguments for a long-term safety disposal facility. So the safety case has been developed to be an overarching document that summarizes and collates these arguments and closes the gaps. In addition to the major aims listed here and the information in these technical supporting documents, the safety case also addresses a number of other areas. For example, management systems, safety objectives and criteria. It also summarizes key safety features, identifies engineered barriers, physical barriers. It's a place where we discuss what the uncertainties in the analysis are. We also discuss things such as third-party reviews of the project, how the project has undergone various design optimizations and iterations of the project at different stages. It also sets a safe operating envelope for decommissioning and post-closure. The safety case has been based on a framework, and there's a figure here that shows the framework, and this is a high level. This comes from the CDC Regulation 211.1 Volume 3, and that requires that a licensee submit a safety case to the CNSC for acceptance. It sets out the minimum requirements that a safety case should address to support a license application for activities pertaining to a disposal facility. There are many possible ways of structuring and documenting the safety case, but for clarity and to assure the alignment with the relevant guidance, the NPD safety case follows the framework shown here. The diagram shown is actually taken from IAEA SSG 23, which is the safety case and safety assessment for the disposal of radioactive waste. And some of the CNSC regulations are actually based around this guidance. These 8 components became the 8 main sections of the NPD disposal facility safety case document, and they show the key components used to produce a safety case that's in compliance with the CNSC Reg Doc 211.1 Volume 3 and also the IEA guidance. As I've already mentioned, the safety case has taken the key elements from the regulatory guidance and the IEA documentation and used them to create a structure for the safety case that mirrors the key elements in the previous slide. These 8 components described the 8 individual sections of the document, and for clarity. In addition, the safety case includes appendices that give a description of the CNL's management system and also concordance table against the Class 1 nuclear facility regulations, Reg Doc 211.1, and also the IEA's disposal of radioactive waste document, SSR 5. The NPD safety case also includes other information relevant to the safe implementation of the project. This includes elements such as the CNL safety management system, the management and administration measures that ensure the claims made in the safety case are robustly supported throughout the life cycle of the facility. It's considered to be a collection of claims supported by arguments and evidence, which are generally assessed in technical and other supporting documents. A quick description of what we mean by a claim, and that is a claim is a property of the system or a subsystem. For example, a system's reliability and performance over time, that will be a claim. This is supported by other things such as evidence, which will be the basis of a safety argument and includes data from various sources such as research, site investigation, characterization, etc. Subclaims are derived from a lower level sub-argument. For example, safety subclaims made in technical supporting documents. To link all the evidence to the claim, an argument is made, and this can be deterministic, probabilistic, or qualitative. But in the case of the NPD disposal facility safety case, we only use deterministic and qualitative arguments. There is no probabilistic analysis performed. We also have an inference, which is how the evidence is brought together to support the claim in a convincing manner. So taking all these things together, we take the evidence, we go through an inference, forms a structured argument, and we demonstrate that the claim has been made. done these claims, we actually start integrating these into a safety argument. Overall, the integration of safety arguments addresses radiological and non-radiological impacts, overall safety of the disposal facility, and overall compliance with the relevant legislation and regulatory requirements. There are quite a few lines of evidence in support of the safety arguments backing up the claims made in the safety case. For example, in the last two slides here, a summary of the arguments that demonstrate that the NPDF provides a long-term isolation and containment as shown here and on the previous slide. So these are some of the arguments that would normally be made. A graphical summary of the arguments can be represented in this, as shown on this slide here. So this demonstrates that the safety arguments of the waste is contained by multiple barriers. The graphical illustration shows how we take the evidence, move through an inference, make an argument, and then arrive at the claim. The evidence in these cases relates to tangible elements that can be demonstrated to be in place at the NPD disposal facility. The arguments are then presented in the safety case and are supported by the modelling analyses presented in the technical supporting documents, such as the post-closure safety assessment. Overall, this supports the claims made, which in this example is that the waste is contained by multiple barriers. Overall, there are a number of claims that are made in the safety case. Some examples are presented here. For each of the claims, they are all supported by evidence and arguments, as described earlier. Overall, the safety case communicates a clear and comprehensive argument that decommissioning post-closure activities and long-term disposal of the waste can be undertaken safely. One of the other things that's actually addressed in the safety case is the use of natural analogues, and this is used to support the arguments and the claims that the facility is able to withstand the assessment conditions, the long-term safety assessment models demonstrates its limit. We've understood its full limitations. In particular, the materials and environmental conditions involved are somewhat different in the analogue compared to the NPD disposal facility and its environment. In addition, the purpose of the structure is not always the same, so many are burial sites, not disposal facilities. And this is typical of natural and anthropological analogues, or man-made to be simple. Therefore, we're using the analogues as additional lines of evidence that does not replace the safety assessment. Nonetheless, these examples support the concepts of the long-term containment provided by the engineered barriers of the NPD disposal facility and illustrate similar long-term behavior in natural and man-made systems. The examples show that the NPD disposal facility barrier functions can be maintained and their regular lifetimes achieved. It can also be inferred from the analogues that the post-closure safety assessment has been conservative in its assumptions, and that the barrier functions can be expected to perform for the time duration significantly in excess of the model design. The NPD disposal facility safety case describes several man-made earthen mounds, all of which were used as some kind of burial or grave site hundreds and thousands of years ago. These sites are well preserved to this day, indicating that humans are capable of creating earthen mounds that resist weathering effects, and that humans are able to recognize these mounds and leave them relatively undisturbed. Some of the examples we use in the safety case are New Grange in Ireland, which is 5,000 years old, maybe more. Sutton Hoo, which is a Saxon burial site in the UK. Serpent Mound, Monk's Mound in the USA. There are various burial mounds in British Columbia that are also used. Canadian Nuclear Laboratories procured the services of Areva Consulting to act as a third-party review of the environmental impact statement, decommissioning safety assessments, and the post-closure safety assessment documents previously submitted to the CNSC in support of the NPD closure project in 2017. This independent third-party review was to show to provide confidence that the analysis performed was good enough, and we were able to demonstrate that the safety in the long term was being met. In addition to the third-party review done by Areva, there was also a third-party review of the post-closure safety assessment, or particularly the third iteration. That was done by the US Department of Energy. If there are any deficiencies identified in the early iterations of the report, they were addressed in the current iterations. Overall, the DOE panel concluded that post-closure safety assessment demonstrated a high level of confidence regarding the overall safety and environmental impact of the proposed activities. The engineering design assessments were also found to be overly conservative. Some of the modelling assumptions, however, they found were non-conservative, and these have been highlighted for further review. A final third-party review of the safety case was performed by the technical experts from both a regulatory perspective and a nuclear waste disposal perspective. They concluded that the overall safety case satisfies the regulatory requirements of the CNSC and the IEA, and are thorough with no fundamental challenges to the proposal. The approach used and results obtained were found to be considered to be broadly consistent with what would be expected for this type of nuclear waste disposal facility. In addition to the safety case, we've also done quite a lot of Indigenous and stakeholder engagement. This began in 2016 and continues to the present, which this presentation is one of the elements of that. So CNL and the NPD closure project have actively engaged the various stakeholders of the NPD closure project, including federal regulators and agencies, the public, local Indigenous communities, and local municipalities. CNL has also conducted a variety of public engagement activities, including presentations, site tours, public information sessions, community events, news updates, employee engagements, webinars. We also have a web page, fact sheets, poster boards. There's quite a lot of these things. We also are on social media such as Facebook, Twitter, and YouTube. These activities have helped to inform stakeholders and have enabled the public to provide valuable feedback into the project, which helps the CNL understand areas of public concern and improve the project design and the environmental impact statement. Most of the key issues that stakeholders have brought forth have been resolved or incorporated into the design of the project and are documented in the safety case and the environmental impact statement. So to summarize, the safety case presents and summarizes a logical and hierarchical set of documents that describe the risks in terms of the hazards presented by the decommissioning of the NPD waste facility, including potential faults and accidents, and those reasonably achievable measures that need to be implemented to prevent or minimize harm to workers, the public, and the environment. So Canadian regulatory guidance has been followed to ensure that the models are relevant, well-grounded, and auditable. We've used best practice guidance developed by the International Atomic Energy Agency. The study also provides currently best available information on the NPD facility, whether there are uncertainties identified or gaps in the data, a conservative approach has been taken. The safety case also clarifies CNL's approach to decommissioning NPD and states the case for in situ disposal of the facility. This safety case and its supporting documents describe the characteristics of the NPD facility, including its design and location, and demonstrate that the NPD facility is a suitable candidate for in situ disposal. Now, the risks associated with this method of disposal are significantly lower than any other viable option. I think with that, I would like to conclude my presentation, so I shall hand back to Mitch.
Thanks, Graham. Appreciate the presentation and the information provided. And I see the Q&A has lit up, so we do have a question. So first question comes from Lawrence Upton. What were some of the non-conservative assumptions highlighted in the third-party review?
If you give me a second, I shall refresh myself. I can't remember off the top of my head. Apologies for that.
Yeah, that's okay.
Yeah.
I should also at this time, introduce some of the other project people that we have on the line. So we also have Katie Shorter, who's also here with us to help answer questions. Katie, why don't you introduce yourself while Graham's getting his answer there?
Thanks, Mitch. I'm the manager of regulatory approvals for the NPD closure project. Work closely with Graham on both the environmental assessment, the environmental impact statement for NPD, and also on the safety case or the licensing side for NPD.
Thanks, Katie. On to you, Graham.
Yeah, it really all related around the modeling assumptions. So non-conservative ones were that it was felt that say some of the things such as timescales for changes in hydraulic conductivity, the actual how we developed those were a little optimistic and kind. So we've gone back and revisited those ones, and we've actually looked at what the figure should be, and we've confirmed that what the numbers are, and we're confident now that the numbers we're using are actually conservative.
Okay, thanks, Graham. I'll just check the Q&A function. Again, reminder to participants, if you'd like to ask a question, just hit the Q&A button. It's in the middle. If you scroll down to the bottom of the Zoom platform there, it's in the middle Q&A, and you click on there, and you can ask any questions. I'm not seeing any. Oh, perhaps there's one. What are some of the barriers that contain the waste?
Yeah, I'll take that. There are quite a few barriers in place. The key barrier is actually the waste form, which is most of the radioactive contamination is actually held within the calandria, which is made of zircaloy and stainless steel, and those are very corrosion resistant. In addition to that, there's also a barrier, which is the grout, which forms an alkaline environment around that, and that ties into the waste form. What that means is it's because of the alkaline environment, it really slows down the corrosion rate of the zircaloy. So it takes a very long time, and that allows the waste to be held up within the metals and allowing time for it to decay away, so that we can hold out there for a significant period of time without actually escape into the environment. Other barriers we have, as we move through the facility, there's the distance. It has to travel through the concrete and the ground. It actually has to go through the walls. Then we get into the actual bedrock that surrounds it. So there's quite as I mentioned early on in the presentation, the facility itself is actually socketed into the bedrock, and where the majority of the waste is actually located is about 88 feet down. So it takes quite a while for it to travel through the actual basement of the building, then through the geosphere and the concrete, not the concrete, sorry, the bedrock, before it actually gets to the biosphere or the environment itself.
All right, thanks, Graham. A question about on the EA process, where we are. Is there an update on where NPD is in the EA process and kind of what the next steps are?
I can jump in and take that one, Graham, if you don't mind.
Yeah, no problem.
So I think Graham covered this really quickly at the start, but I can just sort of repeat some of that information. As Graham mentioned, we submitted an initial EIS, an initial draft EIS in 2017, and we had public, regulator, and Indigenous comments on that submission. So we've been addressing that information, or those questions and concerns since that time, and we're just preparing to submit a revised draft EIS to the CNSC this year before Christmas time, so in December. At that point, the CNSC and the federal review team does another technical review of CNL's package, so the EIS and supporting documents. And it's expected that we might have additional information requests to respond to from the CNSC. So with that in mind, and the work that CNL is doing to continue to address concerns and interests from the public, and especially from Indigenous groups and communities, we expect to submit a final EIS at the end of 2022. So hearings would come after that point in time.
Okay, thank you, Katie. We do have another question about providing a link to all the safety documents, including the safety assessment conclusions and how the evidence is utilized for the conclusions. I know at some point we will put the EIS on the web translated. I'm not entirely sure if the safety documents.
Yeah, I can jump in. I can jump in there, Mitch. So there is
Sure.
a right now the 2017 version of the EIS is available and translated online, and it does provide a summary, especially in the effects assessment portion of the post-closure safety assessment, which really looks into that long-term safety of the facility. Once the revised draft EIS is accepted by the CNSC, our submission next month is accepted, we will post the revised draft EIS externally, and it'll be available in both languages. If there are specific other technical supporting documents that people are interested in, the safety case, the post-closure safety assessment, the best thing to do is to put that request into ERM stakeholder relations email, which I think Margot can probably put the link up for people, maybe in the Q&A. I'm not even sure how we do that, but we can send that out again, and we can provide access to other technical supporting documents.
Thank you, Katie. Yeah, that's correct. Margot can put the email address in our chat, and you can request specific documents, but we can also put the link up to the existing EIS, and then of course when the updated EIS comes up and is translated and on our site, we will also put that link out as well. Okay. Any further questions? Oh. I'm not seeing any more questions.
Getting away lightly.
So, did you circulate the slides already? Well, the whole presentation will be available on YouTube, so you'll be able to see the slides on. It should be up usually a couple days after this presentation is complete. We get the link up there on YouTube where you can watch it again and watch the slides. But if you like the slides, we can certainly circulate a copy of the deck if that's something you'd like. Okay. We will provide a copy of the deck. And just a few more minutes to see if there's any other questions. You have a bit of time. I'll remind everyone that we have 3 webinars today. This is the first one on the NPD closure project, but following this at around 11 o'clock, we will have the NSDF project, which will be presenting on the waste characterizations at Chalk River Laboratories. And then following that at 12 noon Eastern time, but 11 Central Time, we will have the White Shell project, which will be providing an overview of their environmental protection program at the White Shell Laboratories. So hope that you can also join us for those presentations as well today. And again, those will, if you can't make them later in the hours, they too will also be translated and put to our YouTube page for later viewing if necessary. Okay. I'm not seeing any further questions. So with that, is there anything more from Graham or Katie?
No, I think I'm good. Let's just say thanks to everyone for attending and listening to what we had to say.
Oh. Okay. Is there a way to message presenters directly? Yes, we can. If you have some questions, we can certainly send your question directly to the ERM mailbox, and we can provide you some answers to your questions, or direct contact with either Graham or Katie. All right, perfect. Well, with that, I would, yes, echo Graham's sentiments. Thank you very much for spending some time with us today. Do hope the presentation was helpful in understanding the safety case. And we look forward to the presentations later this afternoon, and hope you're able to join us for those. So thank you, everyone, and we'll see you soon.